Hello, I'd like to talk to you about magnetism. We're going to talk about magnetic fields and magnetic forces. Here I have a compass needle that we see lines up in the Earth's magnetic field. This is like a little bar magnet on a needle point here, and when that's free to spin, it will line up when allowed to come to rest. It'll line up so that it is in alignment with the Earth's magnetic field. We have, for example, the north pole of this compass needle points to the north pole of the Earth, and we find that if I bring another magnet up, another bar magnet up here, this bar magnet has a north and a south pole as well, and when I bring the south pole of this magnet up near the north pole of this compass needle, we find that they attract one another. Similarly, the north pole of the bar magnet will attract the south pole of the compass needle. Also, we find that the south pole of the bar magnet will repel the south pole of the compass needle, and similarly the north pole of the bar magnet will repel the north pole of the compass needle. So we find that opposite poles attract and like poles repel. Similarly, I could take a stronger magnet here and bring the magnetic field of this magnet in the vicinity of that compass needle, and it will also have an effect on the compass needle, tending to make the compass needle line up with the magnetic field of whatever source of magnetism we might have the compass needle find itself in. Now what I'd like to do is show you a little bit about the nature of the magnetic field. To do that, I'm going to first of all start off with this bar magnet and just show you that if I take the bar magnet, put a piece of cardboard over it, and then take some iron filings and sprinkle on this cardboard on top of the bar magnet, the magnetic field will penetrate the cardboard, and we'll see what happens when I take these iron filings, sprinkle it on this piece of cardboard. Now what's happening here is that each of one of these little iron filings is becoming as if it were a little tiny compass needle, and it tends to line up in the magnetic field of the bar magnet, even through the cardboard. So those iron filings line up, and we can see the shape of the magnetic field through that paper. Now, here I've drawn a bar magnet with the magnetic field lines shown here, and the magnetic field lines have this shape as we see from our experiment of iron filings on the paper. Similarly, I could take these iron filings, and we'll start over again here. This time what I'd like to do is to show you that we can get the same kind of thing even with this relatively weak magnetic field associated with the compass needle. Let's see if we can get that to show through the cardboard here. This is a little bit weaker magnetic field. May not show up quite as well, but nevertheless, if we vibrate it a little bit, we see we have a magnetic field associated with the compass needle. Now, another place we can show the magnetic field is the magnetic field associated with this rather strong horseshoe magnet. To do that, I'm going to just take these iron filings, get everything out of the way here, put the horseshoe magnet front and center. I'm going to show you what happens when I put these iron filings in the magnetic field of the horseshoe magnet. So there the iron filings behave like little magnets themselves. They're attracted to the strong part of the magnetic field, and up in this space above the magnet we can get what we might call the dance of the sugar plum filings, showing that, let's get a few more filings on there. You see they're attracted to the strong part of the magnet, and we get that magnetic field we can map out by looking at the orientation of the magnetic filings. magnetic field comes out of one pole and goes into the other pole. Just like it does with a bar magnet, comes out of one pole and goes in the other pole. So this is one pole of the horseshoe magnet, and this is the opposite pole.